My name is Michael Hind. I've been in IBM research for several decades now. The last 5 or 6 been focusing on this interesting problem of trustworthy AI. And I know people in the audience have been hearing about this for the last 7 sessions, so I don't need to motivate that. But what I do want to say is that I'm one of about 3 dozen researchers in IBM research working in this general space. As you'll see in a second, there's a lot of open problems and issues here, and I'll touch on some of those things. And of course, even though I'm in research, I work closely with the product team. I also work with customers and hear a lot about what their pain points are. And if there's interest later on, in the Q&A, we can talk about some of those things. Okay, so I'm sure I'll go the introductory slides. I'm sure you've seen flavors of this before. AI is being used more in high stakes applications. You know these examples, I'm sure. And I'm sure you've seen versions of this slide, which is actually 9 slides put together in one slide. Of all different examples where AI has gone bad because of various issues. So you've heard about these things. What I want to do is go to this one. It's just 2 particular examples I want to mention. You're probably aware, but just want to mention. So this first one happened during the pandemic, at the beginning of the pandemic, when the exams in the UK that were typically given to high school students couldn't be given. They couldn't be given across the country. So instead, there was they couldn't give a common exam. They asked the high school's teachers to basically kind of predict what the exam grades would be for each student, and then that rolled into some central place that was deciding, making decisions. And then there was a concern that there might be bias because maybe teachers might favor their students. So they tried to adjust, and the details of exactly what they did doesn't really matter because the perception from the citizens was that this was bad and that somehow the headline, as you can see here, was AI was making some kind of biased decision. And the issue really here was that there wasn't enough transparency. There wasn't enough awareness of what the heck was going on. So people can kind of write whatever they want to write and people are upset. And of course, whenever you're making decisions on who gets to go to the prestigious schools and who doesn't, there's going to be some winners and some losers. And certainly, if you didn't come on the positive end of that, and you hear there may be some issue, you're definitely going to grasp onto that. So I'll come back to this one in a second. The second example I want to spend a second on is you probably heard about this. This was back in November of 2019. It's ancient history, and this was when Apple was rolling out this Apple Card. And they worked with Goldman Sachs, and there was a entrepreneur, this guy's name, I guess he's right there, David Hansen. And he mentioned on Twitter that him and his wife have the same credit history, and that they both applied, and that his wife, he got 20 times a higher credit limit than his wife did, even though they had the same credit history. And then there was others sort of chiming in on Twitter. In fact, one of the co-founders of Apple back in the 70s said, yes, he saw a similar thing. And so there were articles written like this one that says, hey, there's some kind of bias in this credit card. This is really, really bad. And of course, this is not good for Apple and Goldman Sachs. But what you probably don't know, and I didn't know until I think 2 weeks ago, is this piece of information, which is about 1.5 years later, where there was an investigation by the New York Attorney General. Sorry, not the Attorney General, the regulator invested this to see, was there an issue where the algorithm being used was biased against women? And they found out that there was no bias, there was no issue. It turned out the details were not exactly the same, despite what was reported on Twitter, and that the algorithm was okay. Okay. So what's interesting about this was there's an allegation, 1.5 years, there's a report comes out. I, who work in this area, did not hear about this. Maybe you didn't hear about it either, but I think we all heard about the first one. So one of the points here is that even when there isn't a bias, you still can suffer significant consequences as an enterprise because the perception is there was. It's kind of guilty until maybe proven innocent or proven not guilty, but even then, people don't really pay attention. There's not an exciting article to be written as much as there was the first time. And here's just a quote that my colleague Kush Varshney found from the founder, not the founder, the early leaders of IBM, the toughest thing about the power of trust is that it's very difficult to build and very easy to destroy, right? So I wouldn't want to be in that situation where a company gets accused of something, even when it turns out they didn't do what was being accused. So this leads to the general taking a step back and saying, well, why is there all this interest? Why do you have this seminar series? Why does IBM have 36 people working in this space in research alone? And it's because there's a number of different forces that are happening that are making trust in AI really top priority. The first one we just talked about, it's the brand reputation. It's that even the perception of doing something wrong, never mind doing something wrong, is going to really hit your brand, and that just may lead customers to just go elsewhere, not to want to be a part of your offering. Oops. The second one is related to all those press articles. Is governments are getting much more serious about regulation of AI, right? And I'll have a slide on that in a second. And then related to that, but not exactly the same, is litigation. People are being sued by either their employees, by their customers, maybe by their suppliers, because of some concerns with this. So it's sort of two sides of the same coin. Regulation, specifying what you should do or else, and litigation is that threat that, hey, if you don't do something, someone may come after you, particularly if you have a big target on your back. The third one is just the complexity of AI itself, and I'm sure you know this better than I do. It's not simple right now. It's still a little bit ad hoc-ish. And because of that, there needs to be better sort of governance and control internally within an organization, independent of any kind of regulations and so on. And the last bullet is just, right now there's a tremendous amount of focus, rightfully so, on just being fair as a society. And so it's not a good time. It's never a good time, but particularly right now, it's not a good time to be unfair or have AI be unfair.
Can I interrupt? Is that okay? Yeah. So I don't actually see, well, here I would think there is a fifth pillar, but maybe this is under complexity of AI deployments of just knowing that your model is going to do the right thing, right? There's like, it's not even, maybe that ties all these together, but there's just, if I deploy a model to do X, like the credit card's a good example, right? You'd like to empower as many people as possible by giving them the right credit rate, right? And then it's really nothing to do with any of these four things. It's more just, maybe it will build your business more because it's more valuable to you, right? If it does the right thing, et cetera.
Yeah, absolutely. I mean, I bury it under, where you draw the lines is very, subjective, but I would put it under the complexity of AI deployment. So what I mean by that is, in the old days, we used to program, and there was a requirements, and there was, the program should do X, Y, and Z under these conditions. And now we have machine learning. We don't do that anymore. It's great. We're happy. We don't have to program. Programming is hard, but we don't really know what's happening with some of the technologies. So absolutely, correctness, fundamental correctness. And what does it even mean? How do you even know what correctness is definitely an issue, which leads to, complexity, is that and a whole bunch of other things as well.
Sure.
Thank you. Thanks for the comment. Any other questions or comments for? Okay. One slide on regulation. This is not exhaustive. It's out of date, as soon as you write it down. There's a lot of regulations happening. I just want to point out sort of a few things here. The things that are circled. So in the US, there's this regulation called SR 11.7. It's for financial companies. It came about after the crisis about, I guess, 12, 15 years ago. And it basically says that if you're using models, and AI models is one example, but at the time it wasn't really concerned with AI models. It was, you must have a risk management process. In other words, if you're creating a model you're modeling something, you must have separate organizations that manage risk, that assess risk, that validate models, and so on and so forth. And so that's a very serious thing in the US, and other countries have similar things for the financial industry, banking industry. But what's interesting is what's happened more recently is in 2021 in April, the same month, almost the same week, actually, two things happened. The first one is this one over here in the middle, where the EU has been studying this for quite carefully about AI, and they came out with proposed legislation that's going through the process right now with the member countries. And the most significant part of this is it's like GDPR, right? So what they're saying is that if you, on the wrong side of this regulation, you can be fined up to 6% of your annual revenue. Okay, so very serious, just like GDPR, serious teeth. It's not yet been officially applied, and I think there'll be a 2-year period before it comes into effect. But it's happening. It's going to be happening. What's interesting is on the other side of the Atlantic, the US wrote a blog, right? It wasn't any proposed legislation. It was just a blog. And the blog post came from the FTC, which is a regulator. And they basically said, look, in the US, we already have existing laws that say you can't discriminate, and we will use them. So it was basically a threat that basically said, hey, be careful. And I don't think it's a coincidence that came out the same week. I think it's just kind of two different views of the same coin. So there's a lot of things happening here. Again, this is not exhaustive. There's a lot of other things happening as well. So jumping down a little bit into details here, what are we talking about when we're talking about trustworthy AI? And I know different people have different views on various pillars or dimensions and so on. And these evolve over time. If I gave this talk maybe 3 years ago, you would have seen 3 or 4 pillars. Now we're up to, I guess, 8. But again, this is pretty subjective. So the first one, of course, is performance, is making sure the system actually works. There was a task in mind. Maybe it's loan approval. How accurate is the system when it approves loan? And what do you mean by accurate? What's the right way to measure accuracy? Which I'm sure everyone in the audience has studied that in great detail. That's very important, right? You can't have a trustworthy system unless it performs well, as the previous audience member mentioned. Then there's other attributes, right? So another one is fairness, or the absence of bias. I'll talk more about that in a second, and we talked a lot about that in our examples. There's explainability. I'll go into a little bit of detail on explainability. Basically means when a decision was made, can you explain why that decision was made? Uncertainty quantification is a relatively new hot field that's looking at the subject of the confidence of a model and trying to assess it in a real scientific way, right? So for example, you may have worked with models already, and you may see, okay, it gives a prediction and it gives a confidence. And it may be the case that that particular model, when it says I'm 60% confident, and then later on for a second prediction says I'm 80% confident, the second prediction is more confident than the first. What you don't know is 80% mean it's right 4/5 of the time? I mean, that's what it would suggest, but is it making that statement? And what if I had a second model, and the second model said it was 70% confidence? Can I compare that 70% to the 80%? In most cases, the answer is no. And so what uncertainty quantification is trying to do is actually trying to make it more scientifically rigorous, so that when you have a number like that, it actually is meaningful across different models. The bottom left is talking about a different topic, adversarial robustness. And this is saying, how robust is your model to an adversary trying to do various things? One of them, it could be it's trying to define the decision boundary of your model, so that it can potentially change a decision or find out where, what's needed to actually change a decision. There's other technology that's looking at, can it look at the training data and try to figure out if a piece of training data, of a particular row basically was in the training data set or not, right? So it's kind of leaking some kind of privacy information. There's a lot of examples, I'm sure people are familiar, where you can take things like a stop sign, put a sticky note on it, and then suddenly it views it as a speed limit sign, or similar things with audio, for example. Privacy, I touched on a little bit. There's certainly a lot of issues there. You don't want to be leaking data. Data set quality is a very important analysis. Many data scientists do this already, but it's a question of how good is your training data set. And then overall testing, of course, this is not a new topic. We've had testing for software for a while, but also there's this question of what does it mean in an AI space? So what has IBM been doing in this space? There's a lot. I'm not going to give you a sales pitch on what IBM is doing, but I just want to give a high-level 2-slide overview. And if there's interest in having follow-up conversation, I'd be happy to do that. So one, as you would expect, research is supposed to have impact in science, and we've done a lot of things in that in terms of publications and challenges and so on. We've also contributed significantly to open source. I'll tell you about that in a second. These toolkits, and sorry for the acronyms, they don't make much sense right now, but there's various toolboxes we contributed. I'll tell you about that in a second. We've also worked very closely with our IBM product team. There's a product called Cloud Pak for Data that has technology for example, measuring bias, providing explainability, measuring data drift on deployed models that could have been built anywhere. It could be built on Amazon, Microsoft, and so on. And there's another project I'll talk about in a second called FactSheets. And then lastly, we spend a lot of time talking to regulators, talking to international bodies. You can see there's a bunch of them mentioned here. One more slide. This is more of a global IBM slide. Like most companies, back like 5 years ago, we came out with our principles and trust and transparencies. That's nice. That's important. We created an ethics board within IBM that has real teeth. And this is an internal board that looks for any issues of using AI with customers or internally, and basically makes a decision: do we want to do this or not? Is it comply with our principles? And one example was several years ago, we decided to get out of facial recognition industry, facial recognition in general. There's a lot of detail that recently the World Economic Forum wrote a case study. They interviewed a whole bunch of IBMers, and then with a university in Santa Clara, they actually produced a report just describing a lot of things, including the ethics board and so on. So I can send a link to people if they're interested, and a lot of other things as well. Okay, but I think this audience is a technical audience, so let me get down to a little more technical details. So before I mentioned all these different dimensions or pillars, and this is sort of a summary of what we've done in that space, talking about these toolkits. So our approach has been, if you look at anything, look at, say, fairness, right? There's a large number of papers that have been published on AI fairness. Some top researchers around the world publishing them. Sometimes these papers have code, sometimes they don't. But the code is usually, as an example, here it is, use it. But they're not certainly meant to be used in any kind of real setting usually. So what we did with fairness first is we took a whole bunch of algorithms that were put in papers. Some had codes, most did not, and we put them in a common framework called AI Fairness 360. That's what the AIF is, and this allows people to do comparisons. So, for example, just the simple topic of measuring bias, right? It turns out there's 70 different ways of measuring bias in a data set or in a model's decision. And this toolkit has them all. And it allows people to compare and figure out what makes sense in their use case. We didn't create, this is the community creating this. We didn't invent these 70 different ways. It's just what people have published. And the idea is to have practitioners look at this and figure out what's the right kind of metric for their use case, and then that provides feedback to the scientists saying, okay, in practice we've seen these metrics are most useful, and so on. It's a way to sort of accelerate advanced technology in this space. All of these toolkits also have public Slack channels, so there's an opportunity for people to discuss and share things. For example, the one on fairness has over 1,200 people on it, and it's something that these are real people. They have to actually sign up and provide an email address and so on. So there's also other toolkits, as you can probably guess, matching all the dimensions I mentioned earlier. There's one on explainability, on adversarial robustness, data quality, uncertainty quantification, and so on. You may notice some of these have AIF 360 and AIF 360I. What is this I thing? I stands for internal or enhanced. And what this is we have this public open source toolkit that's very popular, toolkits that are very popular, but we also have enhanced versions that have more things that build on top of them. So if companies want to license that technology, we can work with people on that. So if you're interested, if you see something that's in the open source, and it looks a little lacking, or you think it would be nice if I could handle this modality or this kind of technology, there's a good chance we have it in our enhanced version. But we don't, and so the best thing to do would just contact me if you're interested. Okay, so this is a summary slide of some of the toolkits. What I wanted to mention, these first three I mentioned already. They're all open source. They've all been donated to the Linux Foundation. There was a significant pull from other companies, and they didn't want this to be just an IBM governed thing. So we donated them to the Linux Foundation. Donation sounds like IBM gave them away and is not interested. It's the opposite, in fact. IBM was certainly fine with having this being open governance, and we're still much as active, maintaining them and as we were before. The thing on the right is FactSheets. It's not open source. I'll talk more about it in a second. What I wanted to do is I want to talk more about FactSheets, which is looking at the topic of transparency. But before I do that, I just decided I felt like I was doing too high level here. So I want to go a little bit into explainability first, take about 5 or 6 slides, and then I'll go into transparency. So explainability, I think people certainly know what it means in this audience. Here's some headlines. The quotes in the bottom are basically saying we could not deploy a model, even though it was better, because we couldn't explain it. We weren't allowed by law or by our organization to do that. And then you have regulations. GDPR, good old GDPR, has a clause in there that says that if you're using an automated processing system for decision making, then the citizens have a right to meaningful information about the logic. And that the colorful screenshot is from Paul Nemitz, who came to IBM. He's the one who wrote this in GDPR, and he came to IBM, and I raised my hand and said, could you help me define what meaningful information is? I'm a researcher. I want to satisfy this. Can you tell me, what do I need to do to provide meaningful information? And didn't really have an answer, because this is the way apparently regulations work. I'm very naive to this, but what happens is that these regulations need to last many years, if not decades. And they're written typically in a vague general way so that as society evolves, the definition can kind of evolve. So what I've been told is typically these definitions get decided in court cases and challenges, and they may evolve over time. So it's a little unsatisfactory from a research point of view if I'm trying to satisfy this. If I'm trying to find something that is meaningful information, I don't really know if I've satisfied it or not. I have to make some kind of argument that I guess ultimately would stand up in court, which is not what researchers typically do. On the bottom right is just another example. This happens to come from the US. It's the state of Illinois and the city of Chicago. And this particular act was about video interviews. There was concerns that people can use video interviews to score an applicant using AI. And they basically passed a law that said a bunch of things. First one is please tell the applicant you're doing this. But the second bill was nice and simple. It said, explain how the AI works, which I think as a citizen sounds good to me. As a researcher, I'd love to know what that means. What do you mean works? How do you explain anything? So this is what actually attracted me to this field many, many years ago. And this is just a simple box to illustrate how hard the explainability problem is, or how ill-defined it is, right? So in the middle is our black box, our AI system. And around the outside here, I've got different people who might want an explanation, right? So the first one are data scientists or AI experts who have been probably on the forefront of trying to figure out what a system does. And the reason why is they want to debug the system. They want to ensure it's correct. They want to learn the insights and so on. They have deep AI technical knowledge, and they're fine looking at neural nets and layers and so on. Next up is data scientist. It's a developer, not a data scientist, a developer who's writing code. They don't understand AI. They're technical in the sense of code, but they're not technical in the sense of AI. And they may want an explanation for why the model made a particular prediction. On the top is a physician. She's technical in the medical domain, but not in AI. She'd like an explanation that talks about in medical terms, but not in AI terms. Next is a regulator. They want to understand if the system overall is being fair. They may not understand either medicine nor AI. And on the right is my dad. My dad does not understand AI, does not understand medicine. He just went to the physician and said, I've got this thing on my arm. Is it cancerous or not? And he wants an explanation why. Why is it cancerous, right? So clearly, just looking at the spectrum between my dad and a data scientist, there's a huge gap in what an explanation should be, right? So this just helps set the problem space. If someone comes to you and says, I've got a magic technique that's can explain any AI decision to anyone, you probably should not buy anything from them, because this problem seems to be very hard, or they're brilliant and way ahead of their time. So this is just a little demonstration of the toolkit that tries to illustrate this point. This is available on the website, and it's basically picking up on the topic I just showed. The actual toolkit is a bunch of Python code. There's no GUI or anything. This demo just illustrates what the toolkit could do. So here we have 3 different personas: a data scientist, a loan officer, and a bank customer. And it's trying to show you how different techniques, different explainability techniques may be appropriate depending on who you are. So for this example, this is a data scientist, so pretty technical in space. And here we have decisions, and it's basically showing you how a particular feature sort of correlates with a decision. Green means it correlates in a positive way, and as that feature gets higher, you're more likely to get a positive decision. The Y is here is the prediction. Here's another feature, and this one correlates negatively, and you can see it goes down here, and there are particular threshold points. So that's something, if that didn't make any sense, don't worry about it. But this is something a data scientist would like to see, lots of juicy details. Here's a loan officer who's not an AI expert, and they want to know, why was Robert, this column here, why was Robert denied? And here is all the features for Robert. You can think of this as the application form for Robert that got fed into the model. And the reason why Robert was denied, this particular technique is basically saying, you got denied, Robert, because Robert looks a lot like these 3 items in the training data. James, Danielle, and Franklin, all of which the outcome was bad. They defaulted, and these were their features. And it turns out that if you look at these rows here, a lot of the features are similar, right? So basically, it's explaining by example. It's saying, I'm denying Robert because Robert looks like these 3 people, and those 3 people you told me were bad credit investments. So it's this explaining by prototypes. And then finally, the poor bank customer. First of all, I can't give this to a bank customer because I can't tell them about other people who got denied loans, right? It's not appropriate. But a bank customer would want to see something like this. And this is, okay, you got denied. There's 3 different factors for why you got denied. So for example, your consolidated risk markers was 65. And if you got to something around 72, you would be approved, right? So that's good. That tells me, what do I need to do to get a better decision? Similar thing with features here, the average age and so on. And then on the bottom, it tells you which of these 3 features is more important than others. It gives you some kind of quantification, right? So this is something called contrastive explanations. What's interesting in this space is, even though this seems like this is really exciting and powerful, it's actionable, it kind of depends on 2 things. One, I understand what this feature is, right? Consolidated risk markers probably makes a lot of sense to the loan officer, but to me, what does that mean? It seems like it's an aggregate of a bunch of things. And then 2 is, how do I change this? Like, can I change the average age of my accounts? No, right? That's not something I can really change. So it's useful. It's a good explanation, but there's a little more, that could be done to make this better. And then in the toolkit and also the corresponding paper, this is sort of a taxonomy. Don't worry if you can't grok all this. It's basically a taxonomy. Just says that if you're used to explainability techniques like, say, LIME or SHAP, great. But they are basically down here in this particular part of the tree. They're one particular place that one kind of explanations. There's many other different kinds of explanation that you may find more appropriate for your particular use case. And I apologize, I didn't really present this, but if you're interested, there's a paper that just talks about this more. Okay. So that was just a little teaser on explainability. There's a lot more to be said there. Apologies for not doing corresponding, details on robustness or uncertainty or bias. There's similar stories there. In fact, there's online, there's tutorials that we've given anywhere from a half hour, an hour, or 3 hours on all these websites. Lots of videos that people can watch if you're interested. What I wanted to do now is focus on a little bit more of a bigger picture, which is the space of transparency and governance and risk assessment. And it's a project that I've been leading called the FactSheets project. So I'll go through these one at a time, focusing on transparency first. So about 4 or 5 years ago, when all these bad use cases came out about AI systems, a lot of people were calling for more transparency. We need to know how that AI system that was judging people in the UK, we need to know how that works, something more about it. And I distinguish this from explainability, right? Explainability in my mind is I got denied a loan. Why did I get denied, right? So it's usually about a specific instance, where transparency is more about, hey, I want to know how the system works, and is it appropriate for me or for my use case I'm thinking about reusing it. Right? So the concept of transparency is not a new one, right? It's been around forever. And on the left is just some examples of from other industries where transparency was important, right? So just going through them, first one is packaged foods. This is the label in the US. Ironically, it took up 20 years to agree that this was the standard label to be used. And of course, there's been updates. This happened in the 70s and 80s. Some other examples here this is for children's toys. One bit of information: is this toy appropriate for children between 0 and 3? On the top right is a very similar idea, a different domain. It's for appliances in the US. Energy Star, it says, is this appliance energy efficient? Clearly, there's some kind of metric or multiple metrics that measure efficiency, and there's probably a spectrum here. But to make it very consumable to the consumer, they decided 1 bit. They put a threshold somewhere, they measured one thing, and they said, okay, if you're above this threshold, you get the star. If you're not, then you don't get the star. So consumability is pretty important when you're talking about transparency. On the bottom right one here is bond ratings, another example where if I'm going to invest in a bond, I probably should know something about that. So based on these examples, we said, what would be the appropriate thing for AI? What would a nutritional label be for AI? And the first thing we realized is, well, first of all, it's not going to be a label, at least not right now. There's many, many different things that would be interesting to know about an AI system. And in our first paper, we talked about some of the things you might consider, like what is the intended use of the system? Maybe what algorithms were used? What was the training data set? Things like that, okay? And we didn't mean this as to say, we know all the answers, and if you answer these questions, you automatically get transparency. We meant it as a way of seeding the idea in the community to say, okay, let's try out these ideas and see what happens and see what the tensions are. Does providing this information help? And how painful is it to provide this information? Okay. So these ideas and others, there's others in the community that have offered similar ideas, have really picked up steam. So one thing over here I mentioned earlier is the EU. Their proposed regulation is basically along these lines. There's a lot more to it, but the I heard a bit is a bunch of questions, a bunch of information or an audit that needs to be done of an AI system. Similarly, I mentioned earlier about the exams during COVID time in the UK. The result of that uproar was the UK government proposing transparency guidelines, that they're basically saying, if we're going to use an AI model, we are going to propose those guidelines. And last year, I think it was November, they came out with their proposed standard to say, here's a bunch of questions that we think we should provide to the public so they have more awareness of what the AI system is doing. Other efforts are interesting. So this one here is not a regulation at all. This was a bunch of large companies who were hiring, getting software from other vendors to work in HR space. So you can imagine for screening applications, for figuring out who gets a raise and so on. And they were very concerned about potential issues like bias. And so they got together and said, if anybody wants to sell to us, then you must provide the following pieces of information. And it's basically another list of about 50 questions you must answer about your AI system. So I mentioned that not because it's different in terms of the details, but it's different that it's not regulation. It's basically market forces and industry trying to influence what other companies are doing in that space. Okay, so what have we done? The first paper I mentioned up there, we defined this concept of a fact sheet. And also this idea of a template. So early on, we realized that the kind of information that you need is going to depend on the use case and depend on who's going to read the information, right? It's similar to the explainability chart. in that if I have a regulator who wants to know the information, if I have an end user, they're going to want to know different kinds of information. So the template was a way of saying, these are the set of questions that are appropriate for a particular use, for a particular regulation or policies of a company, and so on. After that, we started working with real model developers to say, okay, how would you document your model, keeping in mind these use cases? And so we wrote a paper about that, and I'll tell you the conclusions in a second. But then we decided that, I guess, a few things. One was that you need to be able to tailor your transparency to particular use case. And then there's a question of, well, how do I do that? And that was this paper on a methodology for creating these fact sheets. I'll say more in a second. And then recently we evaluated that. So here's the summary from that second paper. I'll just focus on the bottom here. There was 2 key takeaways. One is that there's not going to be, we don't see right now a magic fact sheet or a model card or whatever you want to call it that's going to be the one that's going to satisfy everyone. You know, the nutritional label, answer these questions and everyone will be happy. We don't see that happening right now. There may be some subset that we decide all use cases, I mean the world, decides all use cases need to provide at least X, Y, and Z, and maybe more. But there's not going to be magic one that's going to fit everywhere. And then the second point is that tooling will be very, very important. That in all these cases, having the data scientists go and build their fact sheet, do the documentation is very, very painful. And it's not something data scientists typically want to do. So you need to help automate this as much as possible. So this led to this topic of AI governance. And don't worry about the term in a second. I'll make it clear. There's basically a bunch of things that are happening. The second one is I just mentioned, this automate documentation during the life cycle. I've heard from numerous companies that are trying to have this documentation and they'd like it to be done as much as possible automatically. So for example, if a data scientist needs to provide information about the robustness of their algorithm, the accuracy of various kinds, and if they measured bias and so on, they do that naturally in their tools, whether it's, you know, in a notebook or whatever they're using. And so it would be nice if that was just captured in a very seamless way, like capturing breadcrumbs, so that later on when someone downstream says, hey, what did you do for bias there? What did you do for accuracy? You can just press a button and get that report because it was captured. Right? That's number 2. Number 1 is taking a big, big step back and saying that companies have these policies and principles, and maybe they have an ethics board, and they would like those policies to be enforced. Right now, what happens is they write them down on a document and they encourage people to read them, and that's it, right? It'd be great if those policies could be enforced, where you can say, hey, we mean when we say we're going to not be biased, we mean you should measure with this metric, and this metric should have a value less than X. And then as I'm producing my models, I could be checking that in an automated way. The third point is to be able to deliver all this information to all the various stakeholders. I'll show you a graphic of that in a second. And the fourth one is even further down the line, which is understanding. Once you have this automated, you can capture insights and be able to understand best practices and reuse in a more responsible way. So here's just a little cartoon. This is a life cycle for model development. Starts over here with a business owner, goes to a data scientist. Sometimes the model is put as part of an application, sometimes it's not. But either way, there's going to be some kind of QA, validation, model risk management, whatever you want to call it, some kind of testing that happens before it gets deployed. And then while it's running, you're going to have various people monitoring things. And so the idea is quite simple, is at every point here, there's interesting information happening that we'd love to capture. Even the business owner, before the model's even created, knows some things. What's the purpose of this model? Why is it being built? That's going to be important if someone tries to reuse it in a space that's close to that, but not exactly that same use case. How important is this model to the enterprise? Is it doing, suggesting marketing campaign, or is it actually figuring out, loan decisions? Right? Those are very different use cases to the enterprise. As you go through, the data scientist captures a whole bunch of information. So all these things we view as model facts. You'd like to record them and have them make them available. Here's another graphic showing same kind of idea. Now my life cycle went down and I simplified it. But basically, each of these personas has different facts. These facts get put into some kind of store, and then what's really powerful here is to take these facts and create reports that are relevant to that persona, right? So there's a few things happening on the right, even though it's just a cartoon. On the right, you see the same information or potentially different information, but it can be rendered different way depending on the preferred tooling of that person. So that could be a PDF, that could be a Jupyter notebook, it could be a PowerPoint slide, it could be a web tool, whatever it is they care about. Don't force them to go into GitHub to go and look at facts if they're a business owner. They don't want to do that. They're a business owner, they want maybe a PDF. Give them a PDF. If it's a data scientist, they want to look at it in a Jupyter notebook, then go and let them, give it to them in a Jupyter notebook. Very simple idea, but it's powerful. The other point here is you may see there are 6 animated people over on the right side and only 4 on the left. And that illustrates that it's not only the people who are kind of play in this life cycle that care about this, but it's also people outside the life cycle, like a salesperson, like an ethics board, like a regulator, like a customer or an end user. They all may be interested in seeing these things. And of course, many of them will not want the Jupyter Notebook version. They'll probably want a PDF. Here's just an example to make it a little more concrete of what I'm talking about. Here's some metrics. Each row here is a metric, and they're grouped in categories about performance, fairness, robustness, and explainability. And then in each column here is different points in the life cycle where a different data set was used to evaluate the model. So the data scientists, as they're building the model, they evaluated it on these various metrics and got these numbers. Then at QA time or testing time, a model validator used a different data set, a test data set, to then do the same evaluation and got numbers, sometimes the same, sometimes a little different. And then finally, when it went out into production, there was an operations person who's looking at it and also evaluating and got different numbers. Okay, so what does this mean? Why is this interesting? It's interesting because now you've got all this information collected, which right now is very hard to do. Second of all, you can look for trends. You can see accuracy. All right, accuracy went down. I expect that, right? Because I'm seeing data I hadn't trained on. But if it went down dramatically, then that would tell me something that, hey, maybe I should try to improve my process in some way, get better test data, whatever it may be. It also allows a data scientist to see what happened when the model was deployed, which again sounds very simple, but it's not really common right now because the data scientist just lives in their world and often don't see what happens afterwards. Likewise, it helps the operations person see, okay, this model, I'm seeing it's getting 92 accuracy. What was the data scientist seeing? Should I be worried? Should I call the data scientist up or not? And so on. So just simple things that most enterprises don't have right now. This allows you to do that kind of analysis. I'm almost finished. Just wanted to mention this website, which I mentioned earlier. It doesn't have any code, but it has lots and lots of examples of fact sheets. And also more information on the methodology and governance and so on is there, and lots of videos and papers. And then I think last slide is, so why is there no code there? There's no code there because we've made this a product. We announced this last August, and it became a product in December. So if there's any interest, anyone, please follow up with me and I can talk to you more in details. I think I should probably stop. I'll just go one more slide. A newer idea that we're looking at is this idea of a risk assessment. This is not a product. This is just a research project we're looking at. If people are interested, we could collaborate. It's basically saying, could you, given a model that's already been built, unfortunately, I didn't do the right things. I have a model. Can I take that model and do sort of a home inspection report on that model? Do a consumer reports analysis on that model, stress test that model to give me a report, right? And so this will give you an idea. On those various dimensions I mentioned, could you give me a score? Maybe it's a number, maybe it's a letter. We still have to work out the details on that, of how well this model performs on these big dimensions, and then aggregate that score in some way. Maybe it's an A, a B, a C kind of model, so that people can know when to reuse this model, how good this model is, and so on. We've spoken to a lot of customers, and there's a lot of demand for this kind of idea, and we're working out, the details of making sure this is actually useful information, leveraging all those toolkits I mentioned earlier. Okay, I will stop there. If there's interest in follow-up collaborations, these are some of the places we can collaborate on, but I'll take questions in the last, I guess, 10 minutes or so. Thank you for listening.